Check. There we go. Hello, everyone. I'm Jason. Sometimes I work on carports. Usually I do it with people watching, but I'll see what I can do. I have one slide, and then we're going to get down to business. We're going to talk about the minimum you need to do to get your openpilot environment set up and get your nice new comma 4 connected to your car. We're going to talk about a demo carport that I put together to try and make this a little bit easier. We're going to talk about kind of the processes I use in Cabana to turn that big scary wall of numbers into something usable, and some of the OpenDBC tests. That's my slide, and we're going to get down to business. For those of you that haven't installed openpilot on your laptop before, more than just like installing on your comma 4, you're also going to install it on a development environment on your PC. You can use Ubuntu, you can use WSL, anything. You'll run this on your PC. I'm not going to do it right now because it takes 5 or 10 minutes to run, and you're all staring at me expecting something more interesting than watching a compile run. So I have openpilot master checked out. And within that, we have OpenDBC, and we have, well, Shane was talking about that PyTest thing earlier. We were trying to fix that real quick. We're going to check out the demo port, and the reason we want that, I'll show you here. Sorry, I had everything open, and then we were trying to fix that PyTest thing. So we have a development template carport that it's not merged into mainstream OpenPilot yet. It's kind of an experiment. I'd like to do this a different way, but we're going to try this for now. It puts in all basic infrastructure so that you can get down to mic off. There we go. The interesting part is our use of the all-output safety mode, and particularly this mode, because with that little parameter on there, it switches OpenPilot into a mode where we're transparently forwarding. We open a relay and we start recording which traffic comes from which side of the bus. That's already running on the comma car. And if we start the car and we do it with the key in, pilot is started up. OpenPilot is started up and has started recording data. And if there's a signal that we want to find in the car, this is a good time to trigger it. Like, let's say I want to find the turn signals. I'll hit the left turn signal, let it go for a minute, and hit the right turn signal, let it go for a minute, and shut off the car. The way that I do this is always based on uploaded logs. You can go to Comma Shop and you can buy a Red Panda, and you can actually do this live just with your laptop. But my method is just to always let the device upload logs. Let's see if my device is online. It is. And it has just recorded a route. No, that's not it. Come on. It hasn't uploaded yet, but fortunately, I have prepared extensively for stuff going wrong. So we have a series of tests here, and I've put together a document that shows some tests you can go through to produce all the signals that OpenPilot is looking for. Wheel speeds, the accelerator, the brake, et cetera, et cetera. So we'll look first at the drive stationary test 1. going to grab that route ID and pull it up in Cabana. And this is going to be a bit of an eye chart. Let me, oh, you know what I need to do is start screen recording. There we go. So this is going to be a bit of an eye chart, and nothing really useful or sensible is happening here. We just have bits that are changing, and we're not sure why. But as there are some general rules here we can use to figure out what's going on. The reason we're using this demo carport is because the comma 4 has multiple CAN buses connected to it, and we can choose which one we're looking at and just show the messages that we care about. And that's going to narrow it down a lot. And then we can filter by frequency, or rather sort by frequency. And from here, there's some general rules. The most important CAN messages, safety-related stuff, wheel speeds, steering angle, et cetera, they're going to be in higher frequency messages, generally 100 hertz, sometimes 50. They're also going to be on lower numbered CAN IDs, just due to the way the CAN protocol works. Those end up being higher priority if the bus is busy. The lower frequency stuff and the higher CAN arbitration IDs, those are all convenient stuff, blinkers, seat belts, stuff like that. You don't need to know if your turn signal's on 100 times a second, but you do need to know wheel speeds. So you can see Cabana here highlighting just the bits that are changing, and the ones that aren't changing are being left alone. There's a lot of activity here. My process is to go through and kind of cut through all the noise, get the noisiest stuff figured out first. And the noisiest stuff is going to be the checksums and CRCs. Every message, or most of the messages you find on CAN bus are going to have a counter and a checksum associated with them. We happen to know the counters on this car are usually located in bits 8 through 11, yeah. And then the checksum is that first 8 bits. The checksum will appear random, but it will cyclically repeat if the rest of the message is the same. But the checksum will just keep rolling it over and over and over. So the first order of business is to identify all of those, because Cabana has a feature where those stop being highlighted if they've been identified. So we can cross off all the checksums and CRCs. Now, I could make you wait and while I go through and mark all the checksum signals and all the CRC signals, but through the magic of having done this yesterday, we can skip to the point where all the checksums and counters have been identified. And as you can see, lots less activity here. So now we're hopefully able to better see what's going on. I'm going to go back to our document on what I did in that drive. So we're looking for the doors. We're probably going to look for the accelerator and the brake first. The accelerator is nice and easy. It's a little further into the route, which is only a couple minutes long. And let's see what we got going here. Don't know what this is, but don't be afraid of marking stuff off just to see what's in there, see how Cabana graphs it for you. Any activity you see could be interesting. Something interesting going on here. No, that's not it. That's not it. If you need any evidence that I have not, in fact, memorized all the CAN IDs, this is it. Okay, so here's something promising. Da, 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 da. So I've highlighted these 8 bits here, or I've made them part of a signal, and you can see a weird pattern here. It goes up and it cuts off. You'll see this when you're reverse engineering. What happens is I marked off these 8, and it ends up overflowing into the next one, and that's kind of a good indicator that the signal's a little wider than you initially thought. Or actually, maybe it starts a little earlier. A little more? There we go. So we've got 3 things going on there. I'm not sure if that was the accelerator or the brake. I think this is the brake, because for the accelerator, we went to the floor 3 times, 100% each time. For the brake, I didn't have the engine running, so this is like a hydraulic brake pressure, and with the engine not running, you get like that NHTSA mandated vacuum boost left over for the first couple times you press the brake, and then there's a little loose. So this is going to be like a brake pressure. So we'll mark that off. And then I believe I did the accelerator before this. So we're looking for accelerator activity somewhere before. Da, da, da. Don't know what's going on there. Okay. I just wasn't in the right place. It was right before the break. There we go. There's our accelerator. I pressed it 3 times, went to the floor, and it went to a full 8-bit width each time. Well, just slightly less. It went to 250. This happens to be a percentage, so if we scale it by 0.4, that'll bring it down to a percentage. 0% when released, 100% when not. So now we've got our accelerator, we've got our brake. And now things are starting to get a lot less noisy. What else did we have in here? We had the doors. So the doors, we'll be looking for somewhere down here. We'll be looking for them in these lower frequency messages, and they'll just be little one-offs that you're going to have to hunt for and see if anything interesting happens. Okay, so right there, I happen to know when I walked past the camera, that was, I opened driver, passenger, rear left, rear right. That's me walking from the driver to the passenger. So I'm pretty sure this one was the driver's door. I got out, shut it, and then I should see a bit flip for the passenger. And then we saw some more while I was typing. And that'll be the rear left. And this will be the all right. So we know this one's going to be like from a BCM or something. I think in the demo carport, I think I called this door states. I can't recall. Let's take a look. So we've got a named message here now, door states, and we can save this DBC. OpenPilot. We're not scrolling. And we're going to save it over the demo DBC. Yes. So now we've got a DBC entry. Now we can teach OpenPilot to read it. Once PyCharm starts back up. Let's go to another signal while it's thinking. Did we get everything out of this route already? We got the doors. I'm going to skip the seatbelt for now. We'll come back to something more interesting. Let's see if we can find the gear shift position. This same route, obviously we start in park, but after I got back into the car, I went to neutral, or rather reverse, neutral, drive, and back again. So I know that this was, where do we put the brake pressure? So we know it's right after this brake pressure, right? Yeah. So we know it's somewhere in like this area. So we're going to zoom in the timeline and play it and see what pops up. I think we got something happening here. Yes. Okay. So these 4 bits here are giving us some interesting activity. They are the same for the whole drive until I'm messing with the gear shift. So it starts at a 5, 6, 7, 8, and then back to 5. So we now know this is a gear position. And we'll go ahead and call this message transmission. And we'll do something extra for this signal because we know what certain values mean. We know that 5 is park. We know that 6 is reverse. We know that 7 is neutral, and we know that 8 is drive. Now this is super basic. I think the thing's got like a sport gear, it has manumatic. There will be more states in here, but this'll do for a demo. All right, let me check how we're doing on time. So going through this whole process for all the signals will not fit in the time slot that I have. Going through an entire carport, and I've done it quite a few times, is probably a long weekend, but we can skip through here and look for some interesting signals like, you know what, let's actually skip to the fun signal. Let's skip to the one that actually controls steering, just to make sure we fit that in. This is a route from a community Macan owner who gave us a stock lane keeping assist route because this particular Macan doesn't actually have the factory feature for lane guidance. The car's capable of it. We turn it on. OpenPilot can use it, but I couldn't get a stock route from it. So we'll come in here and launch Cabana on that route. And because he was in dash cam mode without that special switch to actually open the relay, we don't have all the traffic is present on both buses 0 and 2. So I'm going to cheat here a little bit because I happen to know it's in this message. Let's load. load our demo DVC. And we're going to call this one HCA01 because that's what it's called. We'll mark off the checksum. We'll mark off the counter. And you'll see nothing else is really happening here yet. What we're going to do is skip till it gets out to like a main road. And oh, we got some activity now. So as soon as he went out to a road, he bounced it off lane lines a couple times for us, and we're getting some obvious activity here. Yeah, so these are force inputs from the lane keeping assist system. We're seeing that that jagged edge there again that kind of indicates I didn't make the signal wide enough. So I don't recall the exact width, but it's definitely more. Let's call it 12. See if it. Oh, it was just the endiness was wrong. Let's do this. There we go. So this is the factory lane keeping assist system. When you see him get close to a road edge, it's applying torque, force to the steering wheel to counter that. The Volkswagen family cars, this one is secretly an Audi Q5 under the hood. It shares a platform. The Volkswagen family cars, for steering angles, pretty much any angle, they don't use a signed value for whatever reason for direction. It's an absolute value, and they send a separate direction signal. So we'll call it LKA torque sine and LKA. And there's usually going to be a bit somewhere that's just turned on whenever it's active. In the interests of time, I'll tell you I happen to know it's over there, or at least I believe it is. Make sure I got the values right. Yeah, so on this car, it is a 3-bit field, values from 0 to 8. If we look in the beginning of the drive, there'll be an init value. Yeah, it'll init at 0, it'll go to 3 when it's ready, and it'll go to 5 when it's actually intervening. So as you go through and come up with all of these values, we can take them and plug them into the demo carport, into car state. We put in here, and this is just a test to see how it goes for speeding up carports. These are all the signals that we need to populate. And did we find accelerator position? I believe we did. Maybe I didn't save it. I hope I saved it. Let's do transmission instead. So as we find these values, we can come in here and uncomment the places where we read those signals. Now that we've got a gear shift position, every time car state runs, openpilot will now know we're in drive, we're in reverse. Like openpilot will refuse to engage if you're in park. If you're in reverse, it puts up the reverse display on your screen so you don't look at it like it's a backup camera, et cetera, et cetera. So the process you go through every time is you've got to find the wheel speeds, you got to find brake pressed, gas pressed, steering angles, cruise activation, blinkers, et cetera, et cetera. For purposes of the live stream, I have a really limited time slot. For purposes of nerding out and a group of friends, I'll do this all night if you want to see more afterwards, but I'm sure Julie's going to give me the hook eventually here, and people would probably like to eat. Oh, people are already eating. Good. I'm not holding anyone up. So, questions, anyone? Go ahead.
Type into this demo script.
What do I type into it?
Yeah, like the values that you found, how do you add them in?
So what's happening is when we save this DBC, it goes into car. Oops, I clicked too many times. DBC. This file right here. So we have a transmission message with a checksum, a counter, and a gear position. And down lower in the file, you'll see the value table for gear position. And then openpilot, when it starts up, the demo car port will read the demo DBC for this car, and that way when car state is running, we're referencing that DBC for these signals. So that tells it what message to read, and then this shifter values map that we read up here is what goes down to the bottom of the file and reads that value table, 5678. These names are made up. I made them up just for the demo carport. You can call them whatever. The intent was to kind of be able to skip all this stuff and get straight to the fun part of finding a order in the chaos of this giant wall of numbers. So we can find signals in here all day if you want. But again, I have limited time on the stream. I want to be respectful of everyone else's time. So if you have more questions or you want to see more, I'm happy to. Yes, sir. That's correct.
Is the red panda capable of like seeing it?
So the question is, why don't you see anything from the OBD port that uses CAN? It's a good question, and the answer is there's something like, there is not one CAN bus in this car. There's something like 8, and one of them. So there's a central CAN gateway, which has 6 CAN buses. One of them connects to just the OBD port. There's another one for infotainment, convenience, powertrain, chassis, and extended. And extended is where all the cool ADAS stuff is. That's the bus that we split. That's where the radar is. That's where the camera is, and that's where the like the blind spot radars are. And then there's 2 more at least. There's a fusion bus between the blind spot radars, and there's a fusion bus between the camera and the radar. Neither of those connect to the gateway directly, but the answer to why you don't see everything is because there's 8 CAN buses, and the gateway filters out everything that isn't diagnostic relevant. It doesn't repeat all the other internal stuff on that port. Other questions? So of all the cars in the same model, yes, generally of the same platform. Volkswagen and other manufacturers as well, really good at recycling stuff from the parts bin. It tends to all work the same way. Other Volkswagen cars that use, say, the MQB platform, and there's 20 or 30 of those, it's all the exact same openpilot code that supports it. There's 3 or 4 different VW platforms. They all tend to work very similarly. Other manufacturers, I think all the Honda cars work almost the same way, including like going all the way back from the mid-2010s to the most current CAN FD stuff. They use the same messages, the same signals for the most part.
So does it make sense to start with Q5 and then build on that?
Like the Audi Q5 that this is based on. So it can. You can just start wherever you want. They're very, very, very similar, like 98th percentile similarity. This is just the car that was in front of us. It was the most interesting. We thought it'd be cool to play with at Comic-Con. And we'll come and layer Q5 on top of this. Mm-hmm. Anything else?
Is it right to assume that all information is open in the sense that it's not encrypted, or is there any
So the question is this information open and not encrypted? Yeah, the information is there in the open. It is not secured per se, other than it is undocumented. You get to figure it out, but we have great tools for figuring that out now. Even the checksum and the algorithm for that varies, isn't really intended as like anti-tampering. It's more intended to protect against bit flips as it transits like a CAN gateway. There's CAN network level checksums, and then the payload checksum is intended to protect it end to end. You will hear people talk about like Toyota TSK. You're seeing some cars now, not all, but some implement actual cryptographic signatures on the messages. You'll see that some Toyota messages will have a very random looking signal that's like 16 or 24 bits wide. The fun police have come for you there. It is specifically designed to stop man-in-the-middle attacks, which you might consider that to be what openpilot is doing, depending on your point of view. There's none of that here. It is showing up a little in the field. It's not hit everyone yet. We're seeing plenty of 2025 and 2026 cars come out that have none of this. So it's not been like, oh my gosh, I can't get a car without this anymore. Some Toyota's all in on it, it seems, but I don't think anyone, maybe some new Ford, new GM. I think those are the big ones that I can think of at the moment. But haven't seen it on Hyundai, haven't seen it on VW yet, but we think it's coming. Haven't seen it on Honda, haven't seen it Mazda, Subaru. Mm-hmm. More questions? Great question. Question is, what's the minimum set of signals? And I tried to put together a little bit of information about that. So you need to fill in brake, gas, the cruise state. You really should have like door open and seat belt. And you'd have to have that before upstream, but like if you didn't look at it right away, if you're just developing on your own, things would be fine. Gear shifter, I would go for it right away just because it's easy to find and nice to have, but like you can hard code the carport to drive while you're in development if you have to. You'll need the blinkers in order to do lane changes. Standstill you can do on your own. You'll have to know your steering angle. Steering torque you'll need for lane changes and for the safety model to work right. And you need to know how fast the car is going. Things you'll need to send. You'll need to send whatever the control message is for your car. It can be based on torque. It can be or angle or curvature. And you'll have to figure that out during the process of reverse engineering. All right. Anything else? Well, this is my carporting talk. Thanks for coming.